This is the Millau Viaduct, the tallest bridge in the world. Its highest tower stretches a staggering 343 meters. So high, the bridge glides above the clouds. But this is the team attempting to build this amazing freeway in the sky had to survive landslides, fight winds gusting at 130 kilometers an hour, and weather massive storms as the bridge simply hung in the balance. It's a bridge that pushes the boundaries of engineering to the limits. Imagine building a series of Eiffel Towers, then slinging a 4-lane highway between them, all the way across one of the deepest valleys in France. Impossible though it sounds, that pretty much describes the building of the Millau Viaduct. From the start, the construction team faced 3 daunting challenges. 1. Build the tallest bridge piers in the world. 2. Put a 36,000-ton freeway on top of them. And 3. Erect 7 steel pylons, each weighing 700 tons. And what's more, they had to do this hundreds of meters above solid ground. So high that if you were on top of the Eiffel Tower, you'd still be looking up at this awesome bridge. October 2001, the team break ground. They're required to build a bridge that'll last for 120 years. And to win the contract, the teams promised to build it in record time, less than 4 years. By comparison, the world's longest suspension bridge, the Akashi Kaikyo in Japan, took a full 10 years to build. To up the ante, any delay will cost them $30,000 a day in penalties. There are 7 piers that are numbered from the northern end of the valley. Number 1 will pose problems because of the steep slope. Number 2 will be the biggest challenge since it's the tallest. Crossing the river, number 3 is not much shorter. Then 4, 5, 6, and 7 climb the gentler slope to the south. To begin, the team had to bury the foundations deep in the bedrock in order to support the enormous weight the bridge will place on them. But the forces of nature were stacked against them. Geologists have warned of the risks posed by the region's fractured limestone. The rock is full of cavities that are essential to the local cheese economy. These cave systems, close to Millau, are home to a unique bacteria responsible for the blue mold in the world-famous Roquefort cheese. But what's perfect for cheese could be disastrous for a megastructure. The geologist's diagnosis spelt one thing: landslides. This kind of catastrophe could jeopardize the entire project. Despite the warnings, building went ahead as planned. Then, well into construction, as predicted, a dramatic storm causes a landslide. 4,000 cubic meters of rock collapse around Pier 1. Fortunately, the fallen rock doesn't damage the pier, but the warning is clear. They're forced to divert precious manpower and equipment to stabilize the slope and prevent a repeat collapse. So if the area is prone to landslides, why did they build the world's tallest bridge here in the first place? The answer is simple. In the 1980s, France built a freeway linking Paris directly with Spain. This major artery headed south across the French countryside. while from the Mediterranean, the freeway headed north, until they both hit one of the deepest valleys in France and stopped. Welcome to Millau, France's least favorite bottleneck. The town of Millau is in the mountainous region of the Massif Central, one of the most tranquil parts of France. But in summer, this poor medieval town suffered traffic hell. The locals couldn't take it anymore. Neither could their mayor.
It was terrible for our reputation. When you hear every day on the television and radio, avoid Millau, there's a traffic backup, a 5-hour wait in Millau.
And it's not just the people of Millau. Two drivers crossing the 30-odd kilometers between the freeway on either side of Millau reveal exactly why this bridge is needed. Jamila, in car 33, will cross the new bridge, while in car 22, Jemima will take the old road across the valley floor. Getting straight on the freeway, car 33 approaches the Millau Bridge after just 18 minutes. The only delay is the 30 seconds it takes to get through the toll booth. Then driving at 100 kilometers an hour over the spectacular bridge, she takes just 32 minutes to get to the other side. Car 22, meanwhile, is just beginning the crawl through the medieval streets of Millau. Cyclists, pedestrians, people with dogs all need to be negotiated. Car 22 then has the long haul up the other side of the valley. The final timing is a staggering 1 hour and 35 minutes. Over an hour longer than Jamila, who took the freeway and bridge. It's clear exactly why the bridge was needed, but it took the French government a very long time to get round to building it. 12 years before construction began up in Paris, the Ministry of Transport first came up with a plan. Their head bridge builder, Michel Villogeux, is no ordinary engineer. He's a man who thinks big, very big, like the Normandy Bridge in northern France, the longest cable-stayed span in the world. With this record-breaking structure completed, Villogeux was on to his next, Millau. His plan, another cable-stay bridge, but pushing the technology beyond anything previously attempted, with piers 4 times higher than the Normandy Bridge. The Millau Bridge would not only be the world's tallest, it would be unlike any bridge ever constructed.
When I've shown first the drawing of this bridge to the convenient authorities, they really thought I was crazy.
Villogeux's Normandy Bridge has 2 sets of cables supporting the deck. But he wanted to up the stakes for Millau by losing 1 row of cables, so the remaining line would be forced to do twice the work. More dramatically, the 2.5-kilometer Millau Bridge, instead of having a single main span, needed a whole series of piers to support it across the valley. No bridge builders had ever attempted a multiple-span, single-line cable-stay bridge on this scale before. The French authorities had a problem. Nervous about Villogeux's groundbreaking scheme, they held a competition inviting other engineers and architects to compete with different designs. The winner, Lord Norman Foster, is one of the world's superstar architects. In Hong Kong, he built the world's largest airport terminal. In Barcelona, offices literally hang from a mast on his communications tower. This is a man who regularly contemplates the impossible and delivers.
You know, it's the challenges, and it's one challenge on top of another, on top of another.
And with Millau, one of the biggest challenges was making it fit into the landscape, given it's just down the road from the famous Gorge du Tarn, France's equivalent of the Grand Canyon.
How do you make something which has to be so immensely strong against the forces of nature, look very gentle, very delicate? How do you weave something on that scale into the most unbelievable landscape?
Ironically, Foster's answer was to take Villageur's pioneering scheme, then push it one stage further. He turned an elegant piece of engineering into a delicate work of art by boldly cutting out 2 of the 9 original piers and seriously slimming down the remaining piers and road deck. Foster wanted the bridge to appear as delicate as a butterfly, but this butterfly has to support the weight of 5 Eiffel Towers in gale-force winds hundreds of meters above the River Tarn.